Hello YouTube, welcome to my class and welcome to my YouTube channel S with Sidz. So in the last video we have discussed about light chapter and some of the couple of things. I am just reminding you that we have discussed about the introduction part and some of the wonderful phenomena. Along with that, the confusion part, like light is a wave nature or particle nature, we also got the conclusion. Then after we discussed about the reflection of light and the introduction part of refraction. But soon after we discussed about reflection of light and how does reflection occur, then laws of reflection, basically how the spherical surfaces works as a medium. Next, the image formed by a plane mirror, and after that the schematic diagram of the representation of the concave mirror and convex mirror. So these things we have already completed. If you want to watch this, you can go to my channel and just check it out. Now in this video, we are going to discuss about mirror terms and the rules to obtain image by the spherical mirror. So I am trying to complete all this session between 15 to 20 minutes. So stay tuned. You will clearly understand everything about the mirror terms and how to obtain the image by applying certain rules. And for the upcoming videos, you are going to study image formation by concave and convex mirror, and which is highly essential in terms of CBSE board examination. Then after, sign convention. So without wasting any time, let's begin our class. So there are certain terms related to mirror. So first one is your pole. So I'm doing one diagram so that you can easily understand what is pole. Let's say this is my mirror. So let's say this is which mirror? By the way, concave mirror. Why? Because concave mirror has the reflecting surface inside. So whose surface is the reflecting inside one, that is called concave mirror. So that it is also called as converging mirror. What's called converging mirror? So now if I am taking this particular point to this particular point, the whole diameter will be called as the aperture. This particular length is called aperture. Now here, what is the midpoint of this particular diameter of a particular surface of any mirror? This is called the pole point. If I am taking convex mirror also, now this particular point will be called as the pole point. Clear? So for concave and for convex, hope you understand how to write the pole. And from the pole, what you can draw a line, this is called principal axis. So now this for convex and this is for concave. Clear about this point? Again I am doing another one. So far we have understood this line, this is called principal axis. This point is called pole, and here A and B, let's say A to B, what is the distance? This is called aperture. Now in this principal axis you are going to see several terms like focal length, like your center of curvature. Clear about this point? Because center of curvature is also known as radius of curvature. Radius means if you draw a circle from the center to any of the point of the circle, this is called the radius. Now since it is a sphere, we can clearly say that if you take this is your O point and this is your P point, OP is the radius. So similarly, if I want to cut this, simply this much only. If I want to cut this, let's make it like this. So this is the point P, let's this is the point O. So I have taken as C since I am talking about a mirror, but you can take O also, no problem. But in authentic way, I can take C. So instead of radius, I can simply call it as center of curvature. Clear? And half of the center of curvature, that means PC. If you divide PC by 2, then you will get the focal length, that is your PF. Clear about this point? So focal length is the half of the radius of curvature or center of curvature. So one more final time. So if this is your mirror, this is your principal axis, this is your pole, and let's say this is your center of curvature, and half of the center of curvature will be your focus. And from this point to this point is called aperture. So that's all about the technical mirror terms related to convex and concave mirror. If I'm doing a convex mirror also, this is my pole, this is my center of curvature, and this is my focus. and from here to here the line will be called as aperture. I hope it is clear to all. So here I have written all these points what you're going to understand right now. The center of reflecting surface of a spherical mirror is a point called the pole. It's a particular center point of the reflecting surface. Just now I said that this is the point. If I'm taking this is the mirror, this is the center point, so this point is called as the pole point. Clear? Then after center of curvature also I have explained, it is denoted by the letter C. Clear? And the location basically it lies in front of the reflecting surface. If I am talking about concave mirror, then it is lying in front of the reflecting surface. If I am talking about convex mirror, the center of curvature is actually behind the reflecting surface. That means here. So this is your concave mirror, that means in front of. Here it is actually the front part, in front of basically center of curvature. If I am talking about convex mirror, then it is behind the convex mirror. This is the center of curvature. I hope this is clear. Now, one of the confusion part is basically rising at here. It is not a part of the mirror itself. It lies outside the reflecting surface. So whenever you talk about the center of curvature or radius of curvature, this is not a part of the reflecting surface, because usually this inside or this is the outside. So here are the reflecting surfaces. Clear? Because if you talk about center of curvature, this is actually lying in front of the reflecting surface or behind the reflecting surface. It is not even a part of the mirror itself. This is the point I want to tell you. Now coming to some of the more points. The distance between the pole and the center of curvature is called the radius of curvature. Clear? Already I have explained. And focal length, how to calculate focal length? It is the half of the radius of curvature. That means if I am taking PC as my radius of curvature, then I have to divide by 2, I will get my focal length. So this is my PF. PF means the focal length, and it is represented by small f. Clear? Then after principal axis, here you can see this line or this line or even this line or this line. They all are called principal axis. How to define it? A straight line passing through the pole and center of curvature of a spherical mirror. I repeat, a straight line passing through the pole. So from the pole, it will pass like a straight line. Clear? And the center of curvature also will lie on this particular line. So this line is called as principal axis. And principal axis is normal to the mirror of itself as related to pen. Clear? So for example, if you want to do a mirror at here, clear? So now if I am taking this particular surface as the reflecting surface, clear? So this line will be called normal line. Which line? Normal line. Normal means perpendicular line. Clear? So principal axis is perpendicular to the pole itself. Now coming to aperture, already completed. Principal focus also already completed, denoted by the letter F. This is also done. Now for spherical mirror of small apertures, the radius of curvature is found to be equal to twice the focal length. Usually according to your syllabus, it has been written that if I am talking about center of curvature or radius of curvature, it is actually 2 times of focus, which I have already explained in this particular segment. I hope this is clear. Now the most important and basic thing which actually students skipping related to mirror chapter, image formation by spherical mirror. Image formation by spherical mirrors. Whether the image formed is real, whether it is virtual, whether it is magnified in the size or reduced or even same size, how to calculate all such scenarios, how to remember all these things. Now this is quite interesting. I'm going to discuss this thing right now, so hope you can connect with it. So right now, representation of image formed by a spherical mirror using ray diagrams. Let me tell you 4 rules as per class 10th NCERT. According to those 4 rules, we are going to understand how to draw image. Let's say I'm talking about concave mirror. One side, other side I'm talking about convex mirror. And what are the certain rules, do you know? Rule number 1, it says that if you pass a ray of light that is parallel to principal axis, then after reflection it will pass through focus. Okay, so this rule I am going to apply on concave mirror so as in convex mirror. Let's say this is my concave mirror. Okay, this is the principal axis and my pole at here. So this will be focus and twice will be center of curvature. Clear? According to the rule, you have to pass the ray of light parallel to principal axis. I repeat, parallel to principal axis. If you pass this ray, or even below this line, they all are parallel to principal axis, right? This ray, or even this ray, they all are parallel to principal axis. According to the statement, it says that they will pass through the focus. So after reflection, it will pass through focus. Here also focus. Here also focus. Here also focus. So this rule you can apply in either cases of the mirror. If you're taking convex mirror also, let's say pole, focus, center of curvature, and now you are applying parallel to principal axis. Since convex mirror nature is diverging, so you can say that it will diverge. Clear about this point? Got it? If you pass this side also parallel to principal axis, it will diverge in this way where actually focus apparently positioned. So my point is basically, if you pass any ray of light parallel to principal axis, then after reflection they will pass through the focus. In the case of convex mirror, we saw that it is diverging. In the case of concave mirror, we saw that it is converging. Clear? Now rule number 2, and this is the exact opposite of rule number 1. If you pass any ray of light through focus, then it will pass again parallel to principal axis. That means return after reflection, it will goes through parallel to principal axis. So I am taking concave mirror. This is pole, focus, center of curvature. So I am passing now ray of light through focus. Arrow mark is highly essential, guys. Huh? Okay. So a ray is just coming like this way. Clear? In this way, in this way. So it will go after reflection like this way, parallel to principal axis. If you do the same thing with convex mirror, it will behave like same way. Okay. Let's say I'm taking in this way, pass through focus, it will parallel to principal axis. I hope this is clear. Got it? Exact opposite. Parallel to principal axis, pass through focus, parallel to principal axis. Now rule number 3 and rule number 4. These are the two rules are highly essential. Rule number 3, basically the name itself, backtrace. That means in which way it will pass, in the same way it will return or bounce back. That means particularly I am taking a spherical mirror like concave mirror. This is your focus, this is your center of curvature. So it's only talking about you have to pass the ray of light through C. Through C means center of curvature. If I am passing a ray of light like this way, clear, then it will return in the same way. So this is nothing else, it is called backtrace. Clear? Again in this way also, if I am passing in this way, it will return in the same way. So I hope this is clear right now. What is the meaning of backtrace? So my point is, according to rule number 3, any ray pass through the center of curvature, they will return through the center of curvature. It's a kind of coincident line in mathematics. Now coming to rule number 4. Pole, focus, center of curvature. Clear? If you pass a ray of light obliquely towards pole, then it will bounce back or reflect obliquely through the pole. That means here angle I is equal to angle R. To be honest and precise, in all of the possible cases, angle I is equal to angle R, which is actually laws of reflection, the second laws of reflection, and it is actually satisfied in all of the possible cases. But here actually it is visible. Clear? I hope this is clear right now. Rule number 4. If you pass a ray of light obliquely towards pole, it will return or bounce back obliquely from the pole. Clear? Same thing I can apply for convex mirror. So I am taking the back trace for convex mirror right now. Pole, focus, center of curvature. I am taking from this way. Dot 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 dot. It will return in the same way. Clear? Now here also rule number 4 for convex mirror. If you pass through pole, it will goes through also pole. I hope this is clear. There are 4 certain rules to form any kind of image. As for class 10 syllabus, you need to understand these 4 rules, and out of these 4 rules you have to remember how many? At least 2. Remember means you can at least apply, because whenever you apply at least 2 rules, there will be an intersection point, and this particular point is called the image point, where actually image will placed or positioned. Once more time, if you pass ray of light parallel to principal axis, it will pass through focus. If you pass through focus, it will parallel to principal axis. That means after reflection. If you pass through center of curvature, it will reflect through center of curvature. If you pass obliquely towards pole, it will return through pole also. Clear? In all of the possible cases, angle I is equal to angle R. I hope you understood, and these are the things I have written, the same thing which I have explained. Clear? So through notes you may easily understand this concept even better. Clear? So in the next upcoming video we are going to discuss about image formation by concave mirror and also convex mirror. I'm trying to complete the notes for your betterment. Hopefully you like this video, and stay tuned for the upcoming videos. Thank you.